Reacting mass calculations use chemical equations to predict the amount of product formed in a given reaction from a given amount of reactant. Here's an example. Magnesium reacts with oxygen to form magnesium oxide. How much magnesium oxide would be formed from 12 grams of magnesium? The equation tells you that 1 mole of magnesium reacts with 1 mole of oxygen to produce 1 mole of magnesium oxide. So if we find out how many moles of magnesium there are in 12 grams of magnesium, then we know that we will form the same number of moles of magnesium oxide. The relative atomic mass of magnesium is 24. This means that 1 mole of magnesium has mass 24 grams. So the number of moles of magnesium in 12 grams equals 12 divided by 24. 24 being the relative atomic mass. And that equals 12 divided by 24 is 0.5 moles. If 1 mole of magnesium makes 1 mole of magnesium oxide, therefore 0.5 moles of magnesium would make 0.5 moles of magnesium oxide. The relative molecular mass of magnesium oxide equals 24 from the magnesium plus 16 equals 40. 0.5 moles of magnesium oxide therefore equals 0.5 times 40 equals 20 grams. Therefore 12 grams of magnesium will make 20 grams of magnesium oxide. Let's have a look at another example. It's worth looking first of all at the balanced equation here. This says that 2 moles of sulfur dioxide reacts with 1 mole of oxygen to make 2 moles of sulfur trioxide. We need the 2 here and the 2 there because oxygen comes in molecules which have 2 oxygen atoms. So unless we had 1 and a half, 2 and a half to 1, then the oxygens would not balance. In this we've got 2 times 2, which is 4, plus 2 is 6, and here we've got 2 times 3 is 6. So this is a balanced equation. What we'd like to know here is that if we started with 96 grams of sulfur dioxide, how much sulfur trioxide would we be able to make? First of all, we have to work out the number of moles of sulfur dioxide. So moles of SO2 equals the mass that we have, which in this case is 96, divided by the relative molecular mass, and the relative molecular mass equals 32 for sulfur plus 16 times 2, which is 32 for the oxygen, equals 64. The relative molecular mass of sulfur dioxide is 64. So the moles of sulfur dioxide is 96, which is the amount that we've got, divided by the molar mass, which would be 64. And if we do that calculation, 96 divided by 64 equals 1.5 moles. Now we have to look at the equation. It says here that 2 moles of sulfur dioxide makes 2 moles of sulfur trioxide. Therefore, 1.5 moles of SO2 should make 1.5 moles of SO3. So if we make 1.5 moles, that will be 1.5 times the relative molecular mass of SO3. So let's work out the relative molecular mass of SO3. That equals to the sulfur, which is 32, plus oxygen, which is 16, times 3, 16 times 3 plus 32 equals 80. So the mass of 1.5 moles equals 1.5 times 80 equals 1.5 times 80, and that equals 120 grams. So therefore we have worked out that 96 grams of sulfur dioxide, which is 1.5 moles, makes 1.5 moles of sulfur trioxide, and 1.5 moles of sulfur trioxide has mass 120 grams. So we can cross that out, 120 grams. Some other examples where we have to actually use the equation where the number of moles of product isn't the same as the number of moles of reactant. Let's balance this equation first of all. We've got ethane reacting with oxygen to make CO2 and H2O. There's only two things in the equation that contain carbon, so we need to balance those up. We've got 2 carbons on the left, so we need 2 carbons on the right. There are only 2 things, one on each side of the equation, that contain hydrogen. There's 2 hydrogens there, 6 hydrogens there, so we need to balance them up over here by putting a 3 in front of the water on this side. And now we need to count up the oxygen to balance it with the oxygen on the left hand side. Here we've got 2 times 2 oxygens is 4, and 3 times 1 is 3. That's 7 oxygens. So if we have 7 oxygens, then we need 7 divided by 2 over this side, which is 3.5 oxygens reacting with the ethane. If my question asked me that if I burnt 100 grams of ethane in excess oxygen, that's enough oxygen to burn that completely, how much carbon dioxide would I make? In order to do this, I need to know the relative molecular mass of C2H6, and that is 2 times 12, 2 times carbon, and 6 times 1, so that's 24 plus 6 equals 30. So 1 mole of ethane has mass 30 grams. So how much have I actually got to start with? Moles of C2H6 equals the mass, which is 100, divided by 30. So that's the number of moles of ethane that I have. Now, from my equation, I can see that there's no number in front of the ethane, but there is a number 2 in front of the carbon dioxide. That means that for every 1 mole of ethane that I burn, I make 2 moles of carbon dioxide. So if we look at this here, the moles of CO2 equals the number of moles of C2H6, which is 100 divided by 30 times 2. So we have an answer for that. So 200 divided by 30 equals 6 2/3 moles. Now I simply have to find the mass of 6 2/3 moles of carbon dioxide. To do that, I need to find the relative molecular mass, which equals 12 from the carbon plus 16 times 2 from the oxygen, which equals 44. So then the mass of CO2 equals 44 times 6 2/3 equals, my calculator says that's 293 1/3 of a gram of of carbon dioxide, which is produced when 100 grams of ethane is burnt. If you've been paying attention to this so far, you will realise that what we have to do is that we take the mass of the reactant that we know about and we convert that into moles. So moles equals mass divided by the relative molecular mass, or more correctly the molar mass. Okay, then we use the equation to find out how many moles of the product that refers to, and then once we've found out, converted that in the right proportions by the equation, we then need to convert the moles back into the mass, and the mass equals moles times the molar mass, or the relative molecular mass. Okay, so the only bit here that is remotely tricky is using the equation, and you just use the numbers in the equation to work out how many times we need to multiply the moles of the reactant to convert into the moles of the product.